we're going to take a look at variation in this section. Direct variation is something some of you probably have some experience with. You may not know it, but if you have a part-time job or even a full-time job and you're paid hourly, you have been doing direct variation. Your pay goes up and varies directly with the hours that you work. So let's say you make $7.50 an hour. You can figure out how much you're going to make just by multiplying the $7.50 times the number of hours that you've worked that week. In this instance, X would be the number of hours that you work, Y would be the amount of your pay. So they vary directly with one another. As X goes up, the Y value goes up. That's a good example of direct variation. Everything that you do in direct variation will follow this template, Y equals Kx. K will be the constant, and X and Y will be the two things that vary directly with one another. So let's take a look at an example. Now this problem says find the variation constant and an equation of variation, which Y varies directly as X, and Y equals 32 when X equals 2. Don't you just hate sometimes the way math books phrase things? So sometimes we have to go through and figure out exactly what they're talking about. When they say find the variation constant, they're talking about K. When they say find an equation of variation, they're talking about find K and place it into this template, Y equals Kx. Every time something says that it varies directly, which this one does, this one talks about direct variation, you will use this template equation, the Y equals Kx. So this one says varies directly. You will always pick out the two things that vary directly. This one is easy because it says Y varies directly with X. But if it had said Z varies directly with W, then Z would go where the Y is and W would go where the X is. So the two things that vary directly are the two things that go into our equation. And we simply substitute in the things that they give us. They're telling us here that Y equals 32 and X equals 2. Doing some basic algebra, we find that K equals 16. Now that's what we call the variation constant. So when the problem asks us for the variation constant, which this one did, very beginning, this is what they're asking us for. They're asking for the K. When it says find an equation of variation, we're going to take the K that we found and plug it back in. So Y equals 16x is the equation of variation. Now if we take a look at this problem, it's a little different from the last one in that it's in paragraph form instead of just a sentence. But we just have to go through and find the things that we're looking for. It says the number of centimeters W of water produced from melting snow varies directly as S. So there's our sentence, or a part of our sentence right there, that tells us that we're doing direct variation. The number of centimeters of snow. Meteorologists have found that under certain conditions, 150 centimeters of snow will melt to 16.8 centimeters of water. To how many centimeters of water will 200 centimeters of snow melt? We see that the W varies directly with the S, and if we use our template Y equals Kx, the Y and the X are the two things that vary directly. So we simply put the W and the S in place of our Y and our X. We need to find our constant first. So let's see what we have. It says that under certain conditions, 150 centimeters of snow will melt to 16.8 centimeters of water. So the 16.8 is the water, so that's going to go in place of W. And the 150 is the snow, so that's going to go in place of S. Do your algebra and solve for K. And we find that K is 0.1125. Now, sometimes you'll see this in function notation, and when we substitute this back in, we're going to put the K back into our equation. It's going to look like this. Simply substituting the K in the equation, but sometimes we see the function notation. Remember that Y is sometimes f of x? Well, in this case, S is like the x. So we would have f of S, only it's not F, it's W. So in function notation, our equation might look like this. And this equation we'll always find, if we know the amount of snow, we will be able to find the amount of water that it would produce. So let's look at the rest of our problem. It actually says to how many centimeters of water will 200 centimeters of snow melt. So we simply need, in our new equation that we have here, to plug in the 200 centimeters of snow. If we do our math, we can determine that if we have 200 centimeters of snow, the height of 200 centimeters, we will actually end up with 22.4 centimeters of water. Now, not everything is direct variation. We also have indirect variation. Sometimes this is called inverse variation instead of indirect variation, but it also has its own little template, and its equation is y equals k over x, where k is over the x, and x and y are the two things that vary inversely or indirectly. So we can look at some problems involving indirect variation. So we can look at this problem, and it says find the variation constant. That's what we had before. We're finding k, and an equation of variation in which y varies inversely as x. That's what you're looking for in these problems. You want to know whether something varies directly or inversely, and this is telling you this one varies inversely. So the y, the first one that you come to, is going to go in the y spot. If it had been an m, it would still go in the y spot. Varies inversely as x. It tells you that y is 16. So we just plug these things in that we have. Remember when you want to solve something like this, if it's division, you're going to do multiplication. So we're going to cross multiply these two numbers. And 16 times 0.3 is 4.8. That's our constant. That's our variation constant. That's k. What we want to do now for our equation of variation is take the k and plug it into our equation. That's our equation of variation. Now, we could have gone a step further and then said, find x when y equals something. And we could have just plugged those in and found new values. That's what we're going to do in the next example. And it's going to be more of a word problem. It's going to be something that's more in paragraph form instead of sentence form. So we're going to look at example 4 in your book. So we look at this problem. It says the time t required to do a job varies inversely. There's our key right there. It tells us we're doing inverse variation. As the number of people p who work on the job, assuming that all work at the same rate. If it takes 72 hours for 9 people to frame a house, how long will it take 12 people to complete the same job? We're going to use our template y equals k over x because it's inverse variation. We have to determine what goes in place of y and x. The first thing that we come to says the time, t. That's what will go in place of the y. So we're going to have t equals k over p. Once we get the equation, we have to determine what goes into the equation. Let's see, it says if it takes 72 hours for 9 people to frame a house. Okay, that's what they're giving us right now. They're telling us it takes 72 hours for 9 people. So if I put 72 in here, that's the time, and 9 in here, that's the 9 people. We have our equation, we just don't have our k yet. If we solve here, we see that k actually equals 648. Now we have a constant, and we can plug it back in, and we can actually use this to find out any time we have the time, we can determine how many people it would take to do the job. So, this would be an application that you might need if you knew that you had so many hours to do a job and you need to find out how many people you had to hire to do the job. This one says, how long will it take 12 people to complete the same job? This would be good for estimation purposes if you were actually the person doing the billing or someone called you and said, how long will it take you to frame my house? And you knew you had 12 people that you could hire to do the job. So let's plug this in. Here's our new equation. We want to plug in what we've got. It says we have 12 people. So that's going to go in place of p. And 648 divided by 12 is 54. That means it would take 54 hours for 12 people to do this same job. Now some of these problems will actually have a combination of the two, and you just have to read and find out what's happening. If something says that something varies jointly, that's the same as direct variation. Let's look at a couple of problems that might have some different wording in it so you can see what I'm talking about. Now this problem has quite a lot in it to digest. It says find an equation of variation in which y varies jointly as x and z. So it's saying that this y is varying jointly with the x and the z. That also means direct variation. That means that the x and the z and the y are all on the same level. It's saying that y varies jointly. So y is out here on the left. It's telling you that it's varying with the x and the z. So we still always have our k here when we talk about direct variation. But we also have the x and the z. The problem says it varies inversely with the square of w. Now remember, inversely means that the y and the x were on opposite sides. They were across from each other. So inversely would mean we were going to do division, and it tells us that w is the part that's being varied inversely. And it's actually the square of w, not just w. So we now have an equation to work with. They're telling us that we have y is 105, x is 3, z is 20, w is 2. So we're going to plug all that in and see what happens. We want to make sure we do our math. So 3 times 20 is 60. We have 60 divided by 4, which is 15. And we find that k equals 7. Now the problem did not just ask for the constant of variation, it asked for the equation of variation. So we're going to take this k, we're going to plug it back into our original equation here, and we're going to get a new equation. And here's our new equation. If they went further and said, now find y when x equals 2 and z equals 4 and w equals 8, you would just plug those numbers in and find the y value. So in these problems, it's just a matter of reading what you've got, determining whether you're doing direct variation or indirect variation, checking to see if you have more than one thing going on at the same time, plug in the numbers that they give you, and solve for the constant, and then plug the constant back into the original equation.